This is the main mass of the Kalkaska, Michigan meteorite. This is nickel iron, and this particular meteorite was found in a farmer's field. There are 10 meteorites in the state that are known. 5 of them are finds, so in other words somebody had to find them someplace. All 5 finds are iron meteorites. The vast majority of them were found in farmers' fields. They were out plowing, thought it was kind of an unusual rock, took it home, some for almost a century before they showed it to someone to say it's a meteorite. This particular one here has been sliced and specimens distributed to other institutions and things like that, or to collectors at the time. This is notable because it has a lot of features that meteorites have, and one of the main ones though are the regmaglyphs that you see here. And what regmaglyphs are thumbprints, where material is ablated off as it's coming through the atmosphere, burning off of the piece. It leaves these thumbprints on it. And this one is quite heavy. Most generally what will happen is this will be polished and then etched with acid, so it'll show the crystalline pattern that makes up the meteorite, which only occurs in space, the particular pattern that occurs. This one hasn't been etched, but that's a fairly interesting meteorite, and obviously a Michigan meteorite.
How big was it originally?
Let's see if I've got that. I don't have my notebook with me, so 9.4 kilograms it was originally, so 20 pounds. And this one still weighs considerable. Has considerable weight to it. Here's actually a smaller cut off the Kalkaska meteorite. But the total weight of that, which is one individual piece, is 9.4 kilograms. And it's our 7th identified meteorite specimen for the state. It was donated to Michigan State University in 1964. So not long after the planetarium opened up. Prior to this, the meteorites, a number of them were in the geology collection, Michigan State University. Then they were transferred over to the planetarium, and they had put them on display at that point. But in going through, before I came on board, and when I first saw the meteorites, they were all wrapped in newspaper from about 20 years ago, and put into tubs and then placed into storage. But here's an example of Michigan's 2nd observed meteorite fall, Rose City, and this one had a total weight of 10.6 kilograms. So obviously it's not the main mass that's here, but it is a nice example of it. It's been cut and polished so that you can see the interior, or the matrix of the meteorite. And this one being so dark in that tells us that it had a pretty violent history in space. Collisions, you name it. At one point the stone liquefied and then solidified. But what I've done is gone through and re-inventoried them all, compared them against the original inventory from the 70s, and then placed them into these boxes for public display with a bit of a history that relates to each of the meteorites. Another Michigan meteorite is this large slice of Grand Rapids. The total weight on this meteorite was 51.7 kilograms. So a fairly large piece. The slice that we have here is right out of the center of the rock. Again, this is a find. This is a nickel iron meteorite. This one has been polished and etched, so it shows the crystalline structure. And a nice example of the Grand Rapids meteorite. This one isn't Michigan, but this is from Minnesota. We've got specimens from other states and other countries, actually. This is Minnesota's 6th identified meteorite from Turtle River. It was found in 1953 and recognized as a meteorite in 1968. So a few years went beyond. But the total known weight on this one was 22 kilograms. And this is a slice that has been etched as well to show the structure of the iron. Holbrook, Navajo County, Arizona, was a fall in July of 1912. This is a stony meteorite. It shows the exterior has this beautiful velvety black fusion crust that it gets when it comes through the atmosphere. Many times it's less than a millimeter thick. And then it shows the gray matrix of the interior of the rock itself. This was a total of 220 kilograms in the fall. And what's interesting with this fall is that there were a lot of little tiny pieces produced from it, and an artist's interpretation or drawing of the time period shows the rocks raining down on the people. And literally that's what happened, is the rocks just rained down and you get all these little tiny pebbles out of it. And there's no doubt this is the specimens that we have here are fairly fresh. A lot of times they'll oxidize because of weathering and that, and so it'll turn the gray matrix brown through oxidation. And so these are fairly fresh, which means that they were picked up at the time of the meteorite fall and preserved. Here's one from Canada, Alberta, Canada. This is Bruderheim. This fell in March of 1960. 180 kilograms was the total weight of this particular one. And again, this is a nice specimen, has a nice dark fusion crust to it, and hasn't been weathered. But the rock traveled at 42 kilometers per second. So they travel fairly fast when they come in through the atmosphere. And many times they bury themselves in the ground a couple of feet when they do strike. As we were getting ready to go to the moon, there were 2 meteorite falls in the world that were occurring that gave us what are known as carbonaceous chondrites. And this is some of the earliest material in our solar system. This one was fell in Mexico, Lende, and a couple of specimens. It contains amino acids. The other fall was Murchison in Australia in 1969. So we go to the moon to bring back rocks, and we've got some interesting meteorites that are falling at the same time somewhere in the world. Here's a Mexican one that was found in 1776. So as a Declaration of Independence is being signed, this one was found in Mexico, Toluca. And again, this is a nickel-iron meteorite. It has quite a bit of weight to it. The specimen here is 1,275 grams, and shows the crystalline structure as well. This is an Australian meteorite. This was found in 1931. This is known as the Henbury meteorite in Western Australia. This example is, again, this is actually a stunning example of the meteorite because of the regmaglyphs, the thumbprints that I mentioned, and the patina that it has. So this is one of my favorites out of the collection, I think, just because it is so attractive in it. Meteorites come in all sizes, as you can see, from tiny to large. This one is Forest City, And this one fell in 1890 in Iowa. And what's notable about this one is it was the first court case was held to decide ownership of meteorites. Question was, if other individuals on an individual's property find meteorites, who do they belong to? Well, the court decided they belong to the property owner, regardless of who finds them. And so Forest City established that clearly. One of the things that we do at the planetarium is outreach. And we have put together a kit. Here's actually one of the meteorites in the kit. This is Michigan's first observed meteorite fall, Allegan, Michigan, in 1899. And again, you can see the black fusion crust and the matrix that is in there. In our kit, we also, that we take to schools, is an actual specimen from the moon, a lunar meteorite. And this is Northwest Africa 5000, was found in the Sahara Desert. The actual size of the meteorite was about the size of a bowling ball when it was found in the desert. And so this is just a tiny piece of that meteorite, but you can see the black, gray, and white matrix that it has, reminiscent of the moon, pretty much. So the kids always enjoy seeing a piece of the moon, I think. This particular meteorite here is a palisite, and it has crystals in it. When you hold it up to the light, light actually shines through the olivine crystals that are in it. Less than 1% of the meteorites that fall to Earth are pallasites. So little space gems come out of it. We have oriented meteorites that come through the atmosphere. You can see the dome shape to these. And on the back side you can see where the stone was pretty molten, just liquid stone on the back. And this means that it came through the atmosphere without wobbling at all. Came through cleanly. So it's oriented with the nose or with the shield coming in. And NASA, when they started the space program, knew that spacecraft had to re-enter the atmosphere. And so NASA looked at meteorites for an idea for the heat shields that are on the Mercury spacecraft, or even if you look at it this way, it looks a little bit like the space shuttle, the nose of the space shuttle coming in. We have iron meteorites that are part of our kit too. This one is a Swedish meteorite and shows the crystalline structure fairly well when it was etched. And that occurs as it cools in space after its collision. Because the nickel iron meteorites represent the core of a planet or planetesimal. Another favorite with a lot of people, because they remember this one, is the 2013 meteorite fall in Chelyabinsk, Russia. And so we put together a little display form that shows an individual stone. If you were to cut it in half, what it would look like. Seeing this one here, you can see the black matrix there, and that shows that it had a pretty violent history in space. Lots of collisions in that liquefied the stone. And then, as I showed with the Holbrook meteorite, a lot of little tiny meteorites came out of this, and they lovingly called those Binkst berries because of their size, but probably hundreds of thousands, if not millions, of tiny little ones have fallen as part of the meteorite fall. And but people remember this. Over 1,500 people were injured during it because of broken glass, flying glass, damage to buildings, things like that. Just a pretty notable meteorite fall. for people. The other thing that we have in our kit are magnets, because whether it's a stone or an iron, for the most part meteorites are magnetic, and there are only a couple of rocks, earth rocks, that are magnetic. But for the most part, meteorites are all magnetic. The other thing we have in our kit are just some sheets talking about meteor terminology. It's not a meteorite till it hits the ground. So if you were to try to catch one coming through the atmosphere and you were successful and it didn't take your hand off because of as fast as it's flowing, it would be a meteor, but a meteorite when it does hit the ground, when it comes in. We show the students, this is part of the Dawn mission to Vesta and Ceres, and how it went. A number of meteorites we know for sure have come from Vesta. We talk about different asteroid and meteorite types, where they come from, and this kind of shows us that the iron meteorites come from the core, pallasites from the core and the mantle, achondric or chondric meteorites are crust or dust. Meteorite's probably one of the oldest things you'll ever hold, 4.5 billion years old. To go along with the Chelyabinsk one, we have a sheet that shows us comparative sizes. This is a 747 jetliner. This is the size of the Chelyabinsk meteorite as it entered the atmosphere. So in comparison with that, this is the